Today we're going to talk about the product property of exponents. So exponents are just ways of multiplying faster. So if I have something like the number 2 and I want to multiply the number 2 two times, let's say I'll take 2 to the second power. And then I want to multiply also the number 2, I want to multiply it again times 4 times, and then also times 1 more time, so 2 to the first power. So this is a product because we're multiplying 2 to the second times 2 to the fourth times 2 to the first. If I were to write this in a longer way, I could always just write all of the numbers, right? I could go 2 to the second power, that's 2 times 2, and then I can multiply that by 2 to the fourth power, which is 2 times 2 times 2 times 2, and then one more time times 2 to the first power, which is just 2. And if I look and see how many 2's I've got here, I've got 1, 2, 3, 4, 5, 6, 7 2's. So a way to simplify that would be to write it as 2 to the 7th power. So 2 to the 7th power is equivalent to this first expression. The rule is if I add the exponents of the same base, that's a way I can simplify it. So if I added 2 plus 4 plus 1, I get 7. So that saves me a little bit of work, so I don't have to write it out the long way every time. For another example, think about 6 to the 4th power times 6 to the 9th power. Now if I wanted to, I could write it out 4 times, and then I can write it out 9 times. But the product property of exponents allows me to just add the exponents and keep the base the same. So if I simplify, I keep the base as 6, and I simply add these two exponents and get 6 to the 13th power. This also works for variables like x or y. If I have x to the 13th times x to the 10th, I can simplify that and get x to the 23rd simply by adding the exponents and keeping the base the same. The quotient property of exponents is sort of similar. It's sort of the same thing. So the quotient property, instead of product, we're working with quotients, and quotient means division. So if I have, let's say, x to the 4th power over x, and I wanted to write it out longhand to simplify, I could say x to the 4th power means x times x times x times x. And then x to the first power is simply x. And now I can see this fraction, I can see this quotient, and I can simplify it by canceling out x over x. We agree that x over x is 1. Anything divided by itself is 1. And so I'm left with only 3 x's on top. So I have x to the 3rd power. A simpler way to do that is just subtract the exponents. Since there's no written exponent on this bottom x, I can say that it's 1. So x to the 4 minus 1 is simply x to the 3rd power. So I can also do that the other way around, but we have to be careful with negative exponents. If I have x to the 2nd power over x to the 6th power, I could write it out as x times x, and then I have x times x times x times x. So I've got 2 x's multiplied on top and 4 x's multiplied on bottom. To simplify, I can actually cancel 2 of them here. I can cancel this one and that one, because that's 1, and this one and that one. And so now what I really have left is there's no more x's on top. They were both canceled, but I still have 2 x's on bottom. And so on the top, I would just put the number 1. Another way to write this, since the x squared is on the bottom, I could write this as x to the negative 2nd power. Negative exponents just mean that you put that number on the bottom, or you flip it. Let's see one more example. If I have x to the 4th times y to the negative 3rd power, and I wanted to rewrite it with positive exponents, that y to the negative third power is just telling me put that on the bottom of your quotient, put it in the denominator. X to the fourth would go on top, and then y to the third would go on bottom, and it would be a positive exponent now. So this expression is equivalent to this expression. Now there's one more property I'd like to talk about, and that's called the power property of exponents. If you have a power to a power, so what I mean by that, let's say x to the third power, and then I put parentheses around it, and I take this whole expression to the second power. So to think about how I would simplify that, I'm going to again write it in longhand notation. I'm going to write it out the long way. So I've got x to the third, which is x times x times x, but it's happening twice. So I have x times x times x times x times x times x. And if I go ahead and count those x's, you can see I've got 6 of them. So it really simplifies to x to the 6th power. Now can you guess what the rule is here? If you guessed multiplying the powers, you're correct. A simpler way to do that is just multiply 3 times 2 to get 6. Now let's do an example where we combine all 3 of these properties together. Example. I'm going to do 6 to the 4th power times 6 to the 9th power and divide it by 6 to the 3rd power and take the whole expression and take it to the 3rd power. So simplifying this is an exponent, by the way. It's a little bit too big for an exponent. So I'm going to start with just the top 2 numbers. They're both 6, so I can go ahead and use the product property, which is the first skill we talked about, and I can go ahead and add those exponents together. So now I've got 6 to the 4 plus 9, which is 6 to the 13th power on top, and then I've got 6 to the 3rd power on bottom, and I've still got this 3 on the outside. Now that I've simplified the top, I can simplify this whole quotient, this whole fraction. Using the quotient property, I'm going to subtract my exponents. So 13 minus 3, that would be 6 to the 10th power. And that's still taken to the 3rd power. And now, finally, I'm going to use the power property, which is the last one we learned. I'm going to use that, and I'm going to multiply these 2 powers together and simplify, and I get 6 to the 30th power. And that's it.